Which one you said?
Yeah, 1920.
I've got a simple pendulum. Okay, so those are two separate things. It has a 2 seconds for its period of small amplitude oscillation. Why did it say it's small?
Because that makes it
simple harmonic motion, and therefore reasonable. Which the following equation would best represent an angle theta that the pendulum makes with the vertical as a function of time. Oh, that's nasty. Yeah, what the heck? Well, not only that, but the problem's kind of icky. Well, I mean, it's gonna be going back and forth, correct?
Yeah.
So if it's going to be going back and forth, it's going to be a sine function or a cosine function. So they only give you a sine to choose from. Let's go with one of those. We know what the period is. There's a period, right?
Yeah.
Which means we know omega has to be 2 pi over that period, correct? Go with my equation. Yeah. Which means that omega is equal to pi, which means my equation should have a pi in it somewhere. So perhaps B, and that's it. Because that's the only way to get the right period.
That equation is the 2 pi.
2 pi over the period is equal to my angular velocity, which is really suspicious. It's not really angular velocity, but it's what goes in front of your t here.
Right.
When you use sine or cosine.
That's like the A sine.
Right. And most importantly, that once it gives a period of 2 seconds, the only way to make the 2 second period is that, and therefore I don't have to worry about the rest of that equation. And then, you know, they could throw a curvy, like if theta wasn't theta max, that should worry you because the amplitude should be the highest point. It oscillates back and forth. Does that make sense?
Yeah.
Okay. You got your hand up? Are you good, Finn?
Good, yeah.
All right. Let's do 20. 20. 2 blocks of mass M and M are connected by a light spring. Uh-oh. Why is it light?
Simple harmonic.
Yeah, it could be simple harmonic motion. Mostly you just don't want to care about it, right? I mean, if it has mass and that mass is moving around, we have to account for it, correct? I don't want to think about it, so it's a nice, pretty spring. So don't worry about it. Usually it's going to be a light spring because dealing with springs is really hard. The spring passes over a frictionless string. It doesn't say spring, it says string. Language. A string passes over a frictionless pulley of negative mass and blocks hang vertically. Okay, so I'm redrawing my picture completely from scratch. Are we agreed now that that's the right picture?
Yeah.
Okay. All right, and it says blocks are then released, term rest. What's the acceleration of block mass M? Oh, come on, you can do this problem.
Okay, so
this is what we do.
This one.
Want to find acceleration? What are we talking about? Are we talking about energy?
No.
Are we talking about momentum?
No.
Are we talking about forces?
Yeah.
Okay, let's talk about forces. What forces are on this thing?
Force of weight.
Force of weight. Mg and little mg.
And then tension.
But the tension is going to pull both ways, right? If we're talking about how the system moves, we don't care what the string is doing. The string's like the middle of my arm. If you're asking where I'm going, you don't actually, oh, his arm has tension in it.
So that would be M, big M plus little m.
All right, so that's so I would go F net equals the sum of all forces. But since this is on your multiple choice section, I'm not going to write all this down, right? So you may write big M plus little m. I would write MA equals F1 plus F2. But we're going right to here because you understand the problem.
Yeah.
Acceleration I don't know. What's my forces?
And big MG. And so does it matter which one you do? Like, wouldn't there be negative?
There is a negative. There has to be a negative somewhere. I don't care which one you pick negative for our purposes.
Even if they ask you for.
Well, the deal is you're going to end up with a weird negative if you choose wrong.
Okay.
It's all right.
And then you solve.
I mean, they want to acceleration to block M, but they don't tell you whether up is positive or up is negative, right? Yeah. And that matters in this problem because that block was going to go down. We know that. So which way is it supposed to be? So the answer to the question is they're not going to give you both choices, right? Unless they say in the problem up is positive direction, which they don't. So we'll do the problem. I get A equals, I got big mg minus little mg all over big M plus M. So that minus is negotiable. The rest of it should be good. Oh, they dropped the G off the back. So it's got to be an M minus M over an M plus an M. Only one choice fits that.
Okay.
Okay, so we just discovered that Mr. Rock should guess E whenever he doesn't know the answer to the question. Money. 26, same sort of thing, pulley. All right, two blocks are joined by light string. Oh, I love light strings. Why are they talking about the radius of the pulley, though? No! The pulley is going to be a problem. I can feel it already. Oh, it's so nice when the pulley doesn't matter. Life is good.
Wait until they give the string mass.
Yeah, that's a whole different. That's a fun one. That's when you see them talking about the mass for the length of the string, skip it. At the very end of the test, you have a lot of time left over. Go back and look at the mass of the string problem. E, yes. Get ready to put E in. If they say you got to have to put your pencil down in 1 minute, go back and put an E next to your lightweight string problem. All right, let's see if it works. Two blocks are joined by a light string that passes over a pulley as shown, which is radius R and moment inertia I. That's really bad that it has a moment inertia. We're kind of hoping these are light pulleys. That means that we're going to have to use that strange situation where we're going to use part of our force to pull the pulley, right? Yeah. All right, so we keep going. The tension of the strings on each side of pulley, T1 and T2 of the post. Alpha is the angular acceleration of the pulley. That's nice, actually. Maybe this isn't the problem I think it's going to be. Which of the following equation best represents the pulley's rotational motion during the times the blocks accelerate? Oh, that's nice. Why is that nice?
I have no idea.
Because I don't care about the blocks. They're outside my system. I'm not going to deal with the blocks. I don't know what the blocks do. Not my problem. The tension on the rope's what's making me go, right?
Yeah.
Yeah. So then I'm going to go torque net equals the sum of all torques. Take me the rest of the way, Mr. Rock.
Well, it's the first torque. Second torque. So
Okay, so it could be a torque 1 and a torque 2. Are they pulled the same way?
would it be
They're trying to turn the pulley the same way.
torque 1 plus torque 2?
Are they, question mark. Answer my question, then you know it's a plus or a minus. Are they pulling the same way?
No, they're not.
They're not. So it's going to be T1 minus T2, right?
Would it matter if it's T2 minus T1 or something?
Doesn't matter as long as I'm not worried about direction in which the pulley is going to rotate. So I know which way the pulley is going to rotate. Let's not even worry about it. What goes on the left side?
What if mass are really heavy?
Inertia times the acceleration.
Acceleration. And they gave us inertia, and they gave us acceleration, so life is good. What they didn't give us is torques. You need to fix these torques and turn them into something else.
Well, they did give us torque, right?
No, they didn't. They gave us tensions in the rope. How to turn tensions into torques.
That's something cross radius.
Yes, force cross radius.
No, the tension is the force.
Tension is the force. So it's going to be T1 cross radius. Now, is cross product, have to worry about the cross product? No, it's perpendicular, so cross radius minus T2 cross radius. Now I look through my choices. They actually, on D, they collect like terms. So they pull out the R. Does that make sense?
Yeah.
And that's it. So that shouldn't have been that bad, right? You should look at that and go, oh my God, this looks like one of those awful problems where you have to figure out the I, the portion of force that's going to pull the thing in a circle. But you don't need it in this case. All right. Lightweight plastic ball falls from the floor from a height of a table of 3 meters above the lab. The student predicts the fall will be generating G of 9.8 meters per second squared. It finds the measured time with it to be 35% greater. Which of the following is the most likely cause for its error? All right, so if I got 35% greater time, the ball is falling faster or slower?
Slower.
Right. So the ball's falling slower means my 9.8 is inaccurate. Now, is it 9.8 because I'm in a weird place, or is it because something else is involved? Let's get our choices. Acceleration of gravity is 70% greater than 9.8 dislocation. Well, first try it. 70% greater?
Yeah, that's fine.
Ugh. Yeah, I'm going to cross out A because it's got to be less, right? The acceleration of gravity is 70% less. Okay, that's a possibility. C, air resistance. Ah, this is the one I was looking for, but it says increases the downwards acceleration. Does air resistance increase the downwards acceleration? No. It said decrease. That's the one I picked, honestly. But it didn't say that. So let me try D. The acceleration of plastic balls is not uniform. If you circle that, they should automatically give you a 1 for the test.
Which one would that be?
The acceleration of the plastic balls is not uniform. Or Galileo, they all fall down. Plastic balls are not truly spherical. You tell they were looking for an E answer,
Yeah.
and they didn't have one, and they just kind of threw that in there last minute and hoped for the best. So it's got to be B, because no one slows it down, right? And that's the only thing in there. So be aware, Epicentral does this a lot. You're looking for the reasonable answer. You might even anticipate the right answer. There's only one that's even possible, right? The other ones are just ridiculous. Is that okay?
Yeah.
All right. It's particularly true.